Hi everyone. Today let's quickly summarize the problem that I need to solve in a time calculator project from freeCodeCamp scientific computing with Python. So for introduction, the main goal of the project is to create a function called addTime, and that adds a duration to starting time and then tells me what time it will be after the addition. So here we have three arguments in which the optional argument is day. So the start would text, for example, a 12-hour clock format, like 3 p.m., for example, but in a format like 3 semicolon 00 p.m. and a space between them, yeah, just not just like a normal string, and the duration like 3 hours semicolon and 10 minutes, and the day can be Monday, Tuesday, Wednesday, and so on. It's just a usual day in a week. So and then return after the checking. It will return the function will return the updated hour and minute in the desired format, which is we will take a closer look later on. And whether it's AM or PM, the function also have to deal with this problem. And the day of a week, Monday, Tuesday, as I said earlier. And it also mentioned how many days later after the new day is. And the some example for the function to work. Here we can have the argument start equals to 3 p.m. Duration is 3 hours and 10 minutes. So then we're going to return 6 and 10 p.m. 6 and then another example is start is 12 and 30 a.m. And then duration is 2 hours and 32 minutes. The day is Monday. So we're going to have the returning. Our output is 2 and 2 p.m. Monday. So some of the details we need to take into account is the function should roll over to the next day. For example, if the addition time is if the addition time make the final hour and minute to the next day, we have to print out, for example, a string next day like this, and it should be printed at the end of the whole string, and it should change from AM to PM uh, inversely, and and it should go several days ahead, even up to a week or more. So bottom line, I was building a mini time calculator that takes in the time and duration, and then figures out correctly the new time and day. So this helps me practice working with strings, time logic, and optional inputs. So that's the summary of the time calculator problem. So I'll leave my journal blog, which is the notebook how I did this project at home and a source code Python in Python via GitHub, and you guys can have a closer look by accessing them. But now I only share what my honest experience of what blocked me while working on my Python time calculator project. Yep. So even though I was excited to build this function, I faced a few problems that made my progress slower than I expected. And I hope by sharing this, I can learn something more about these mistakes again. So first, I misunderstood how to calculate days correctly because I tried to find how many days passed by dividing hours by 24, but I didn't check carefully how minutes could change the total hour count. And this caused some bugs in how the final day was printed, especially when minutes added up to new day. Like, and here is the refined code after I fixed the errors. So the lesson is I need to always check how small units like minutes can affect the bigger ones like hours and days. And Second, I made a small mistake when converting the 24-hour format back to 12-hour format. For example, let me see, convert this one. Yeah, this block is a refined one. But before that, I I overcomplicated the code very much, and so when the hour was 12, I didn't handle it correctly. Sometimes it showed 0 instead of 12, and sometimes the AM or PM was not switched right. So lesson learned here is I need to carefully test the edge cases like 12 AM or 12 PM because they behave differently from other times. And third, I again overcomplicated the logic of calculating the final day of the week. As I used extra steps and subtracted one from the day index in a confusing way, like which sometimes gave a wrong day. So here, I used to subtract one from this and day index because I thought that uh, because the list of days it would start from 0 as a Python rule, right? And then I subtract one. But actually, here we already have that because day index and a we already have this because they capitalize it, which means that days index, which already a retrieval method um, of the exact index within this list. So I don't need to subtract one. Yep. And the lesson here is like I shouldn't overthink and just use simple math and built-in tools like modular when dealing with cycles, like weekdays. So fourth, I didn't use enough helper functions. All my logic was in in one long function, as you can see here. Yep, right. Defining the function starting here, and then lastly, the return. And this really made it hard to debug. And now I understand the value of breaking code into smaller and testable parts. So lesson is I need to write clean code, uh, and this is not just for beauty, but it saves time when something breaks. And finally, I didn't write a unit test while developing. I tested by printing the results manually each time, which wasted and made me miss small bugs. So lesson here is I need to write a unit test early. It gives peace of mind and helps me trust my code better. So bottom line, what blocked me from finishing this project wasn't a lack of motivation. It was lack of planning and attention to small details. E- 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 even e- even I so here what I planned out for what how the ideation process I did before I started coding anything. It was manually done. It took me hours to complete this. Even I did this, right? I still got a lot of bugs after I really started with the coding. So now I feel more confident and I learned that coding is not just about writing something that